Hello, everyone. Today we will learn about the vegetable plant seedling technology. The goal of studying this technology is to help you understand the significance of plant seedling, the selection and preparation of plants, and master the formulation and treatment of substrate, and the vegetable seedling management techniques. This lesson will cover the following key topics. 1. Overview of plant seedling technology. 2. Selection and preparation of plants. 3. Formulation and treatment of substrate. 4. Sowing and seedling management. 5. Pest and disease control and strong seedling cultivation. First, let's explore the relevant knowledge about plant seedling technology. Plant seedling technology is an efficient method for vegetable seedling, utilizing lightweight soilless materials as a substrate in plants with various holes to achieve precise seed sowing and uniform seedling development. This technology offers several advantages, including seed conservation, reduced land usage, improved seedling quality, and enhanced production efficiency, making it widely applied in large-scale and factory-style vegetable production. With the advancement of modern agricultural technologies, plant seedling technology is evolving towards precision, automation, and standardization, presenting broad application prospects. Next, we will discuss the selection and preparation of plants. It is essential to choose plants based on seedling requirements, considering the appropriate materials and specifications of plants. Plastic plants are widely used due to their economic efficiency and durability. Plants can be made from various materials, such as polystyrene and expanded polystyrene. Among these, polystyrene is one of the most common materials for seedling plants due to its properties such as resistance to brittleness, aging, and deformation, making it particularly suitable for vegetable seedlings. Now, let's look at the specifications of plants. A size of standard plant is 540 millimeters by 280 millimeters, which is suitable for most seedling scenarios. Depending on the diameter of the holes, a 72-cell plant is ideal for cultivating small to medium-sized seedlings. The choice of plant should be based on the type of plants, seedling age, and cultivation goals. For instance, vegetable seedlings typically use a 50-cell plant. Before use, plants must be cleaned to remove residues and disinfected to eliminate pathogens and pesticides, ensuring sanitary conditions for a healthy growth environment. After thorough cleaning and disinfection, plants can be reused, but attention must be paid to their integrity and durability to prevent the spread of diseases and pests. Next, we will learn about the formulation and treatment of growth media. The substrate usually consists of a mixture of peat moss, vermiculite, and perlite, providing good water retention and aeration while supplying necessary physical support and nutrients for the seeds. The formulation should be adjusted based on the vegetable species and seedling stage to ensure suitability. A common ratio is 2:1:1 or 3:1:1 for peat moss, vermiculite, and perlite, which balances water retention, aeration, and nutrient supply. Additionally, substrate disinfection is crucial to prevent soil-borne diseases. Common methods for substrate disinfection include physical disinfection and chemical disinfection. Physical disinfection includes high-temperature disinfection and solar disinfection. High-temperature disinfection uses steam or hot water to disinfect the substrate, while solar disinfection involves placing the substrate in a greenhouse during summer heat, covering it with plastic for several days to utilize solar energy for sterilization. Chemical disinfection involves mixing agents such as formaldehyde and chlorothalonil into the substrate. When filling plants, pre-moistened substrate should be evenly filled and compressed to ensure consistent sowing depth, promoting uniform germination. Now, let's proceed to the sowing and seedling management. Similar to vegetable sowing seedling technology, high-quality seeds should be chosen, along with pretreatments such as disinfection and soaking to enhance germination rates and seedling quality. During sowing, Seeds should be sown according to the type of vegetable and seeding requirements, controlling sowing depth and evenness, while covering with appropriate materials to provide a conducive germination environment. As seedlings grow, we need to adjust environmental factors such as temperature, humidity, and light according to their growth stages, ensuring healthy development. Finally, we will cover the pest and disease control and strong seedling cultivation. Pest and disease control should adhere to the principle of prevention first, integrated control, using agricultural, physical, biological, and chemical methods to effectively control the occurrence and spread of pests and diseases. Common diseases in plant seedlings include cataplexy, root rot, and stem rot. Their occurrence is often related to inadequate environmental control, improper management, or the presence of pathogens. Control methods include environmental management, substrate treatment, fertilization management, ventilation, density control, and chemical control. Common pests in plant seedling include leaf miners and aphids, which can harm seedlings by sucking sap and spreading viruses or bacteria. Control methods include environmental sanitation, physical control, biological control, and chemical control. Cultivating strong seedlings requires clear identification of their characteristics and cultivation techniques, along with scientific management measures to produce healthy, uniform seedlings. Controlling the environment for strong seedlings involves regulating factors such as light, ventilation, and temperature to provide suitable growth conditions. Light is crucial for seedling growth and development, requiring consideration of light intensity, duration, and uniformity. For example, different crops and growth stages have varying light intensity requirements. Generally, light intensity should remain below the saturation point to avoid light inhibition. An appropriate temperature range is vital for crop growth, and we must understand diurnal temperature difference, soil temperature, and air temperature. For instance, a suitable diurnal temperature difference promotes healthy seedling growth, typically requiring nighttime temperatures to be 5 to 10 degrees Celsius lower than daytime temperatures to help seedlings accumulate nutrients and enhance resilience. Moisture is an indispensable factor for seedling growth. The substrate moisture content should generally be maintained between 60% and 80%, with higher substrate humidity, 80 to 90%, recommended immediately after sowing. Additionally, watering should ideally occur between 9 and 10 a.m. Throughout the seedling process, it is essential to balance moisture control and temperature management. In this lesson, we have covered vegetable plant seedling, understanding the fundamental concepts of plant seedling, mastering formulation and treatment of substrate, sowing and seedling management, pest and disease control, and strong seedling cultivation. After class, please think about the following questions. That concludes today's lesson. Thank you all for listening.